Okay, so hopefully you're not distracted too much by that turtle drawing some polygons. So in this particular video, we're going to look at generalizing our code where we can draw any particular regular polygon and not just a square like we did in the last video. So it's really important whenever we go about designing procedures or functions or methods, whatever appropriate name should be depending on how they're being used, that they perform some specific task, some well-defined task, but that task can have a general form. It takes on a specific form whenever we supply some sort of parameters. So we could supply maybe the parameter of how many sides of a polygon that we actually want to draw. So before we get started writing some actual code, let's take a look at a website called Math is Fun, and we'll review some of the basic concepts associated with polygons. Okay, so we're over here on this website called Math is Fun, and they have a particular web page about polygons, and they define a polygon as just simply a plane shape with straight sides. So we're not going to go into a lot of the details associated with polygons, but just to get a general idea or try to review maybe what a polygon is. I'm assuming that most of you probably have had basic math or basic geometry where you've discussed this concept of polygons, and I guess it's formally discussed before you probably take a geometry class in high school. So they give us some examples here of what is a polygon and what's not a polygon. This particular polygon here is what we call an irregular polygon, since it appears that the sides are not all of the same length. And these two things here are not, in fact, polygons due to the curve and due to the opening that we have here. They have another web page, though, on this Math is Fun website that talks about the interior angles of polygons. And it starts off discussing the interior angle associated with a triangle and how all the interior angles in a triangle sum up to 180 degrees. And it turns out that all the other polygons that we can have could actually be thought of as being composed of triangles. So they have an example here of a square, and we can think about a square as just being composed of two triangles. So if you summed up the angles that we have in two triangles, we know that that sums up to being 360 degrees because we got 180 and 180 degrees. And the same thing can be said for any particular polygon. So they give another example here with a pentagon. So with a pentagon, we're now dealing with 5 sides instead of 4 sides, like a square. And we can think of that being composed of 3 triangles. So since we have one more triangle, we have another 180 degrees being added into the sum of the interior angles. So we would end up with 540 degrees for the sum of the interior angles. Toward the bottom of this particular web page, dealing with interior angles on polygons, they give a general rule. So if you look at this particular table here, and they have a listing of various polygon shapes, the number of sides associated with them, the sum of the interior angles, and then the value associated if we're dealing with regular polygons, the value that would be for each individual angle in that polygon. So the general form, or the general rule here for any polygon, the sum of the interior angles is just simply the quantity of n minus 2 times 180. So if we were to think about a triangle, that's a 3-sided figure, so we'd say 3 minus 2, that would be 1. So 1 times 180, yeah, 180 degrees is the sum of the interior angles for a triangle. The case of a square, it's 4-sided, so it would be 4 minus 2, so 2 times 180, 360. And if we wanted to figure out the value for each individual angle in a regular polygon, we'd just take this quantity here and divide it by the number of sides. And so that's the formula that they have over here. And the really cool thing is that we can take this fact and apply it in a program so that we can draw any particular polygon or any particular regular polygon that we'd like to draw. So let's take this particular fact over to PyScripter and make use of it in a program so that we can draw any particular regular polygon that we desire. Okay, so now we're back over in PyScripter, and we're going to just write some code or write a procedure so that we can draw any particular polygon using that information we learned from the Math is Fun website. So the first thing I want to do is just get rid of this default stuff that appears whenever we create a new module in Python. We'll come back in a later video and discuss what all that means. So for right now, since we're going to be using our turtle module, we want to import turtle. So that's importing the turtle module. And then we'll create a particular turtle and assign it to the variable t. So this is just for convenience. So we'll say turtle here, open paren, close paren, and that is going to be associated with this variable t. So anytime we want to do something to our turtle, we just do it through that variable t. And then we'll do t.showTurtle. And then once we have that specified, we can now change the shape. So that's just t.shape, and then specify the shape of a turtle by specifying a string with the character sequence turtle, all lowercase. And then the next thing we'll do is something new. So the previous 4 statements we saw in our last video, but this next thing is a bit new. What we want to do is get the screen, the background that the turtle is going to reside in. And so the way that we can do that is by doing t dot and then get screen. So we do get screen. So we're going to call that particular method there. And we're going to assign this to a particular variable. So we'll just assign it to the variable ts, which will stand for turtle screen. And then we'll do ts dot and do bg color. And do an open paren, and then do double quote, and then specify black. So you may already know what this is probably going to do. It's going to change the background color. So that's what that BG color stands for, background color of the screen that the turtle is going to be on. So the turtle can be a different color, and then the background can be a different color. And we're going to make the background black. By default, it's white, if you remember from our last video. And we're going to change the color of our turtle to yellow. So we'll do t.color, open parentheses, and then we'll say yellow. And that's pretty much it. So let's go ahead and just test out this code just to see if it actually works. So we'll go up here and run this. And whenever we run it, you see that we now have a black background and a yellow turtle. So now that we have this code and know that it works, let's go ahead and write our procedure to draw a polygon, or at least any type of regular polygon. So in order to define a procedure, once again, you need to use the keyword def for defining. And then we'll just simply name this particular procedure draw underscore, I'll say R polygon for regular polygon. You can name it whatever you like, but I think R polygon for regular polygon is a pretty good name. And then what we're going to do is pass in the number of sides. So we'll just use the variable n, since that was the same n that we had in our formula to represent number of sides. And now if we think about it, in order to draw a polygon, we need to be able to draw some number of sides. And so those sides are going to have, each side is going to have a particular length. So we can imagine we have to do a triangle, it's going to have 3 sides, a square, 4 sides, so on and so forth. So you can think about us doing the same operation each time. It's just that we got to draw a side, move some angle, draw another side, move some angle until we complete that particular polygon. So you can imagine that we're going to have a for loop. So I'll go ahead and say for I in range, and the range that we'll define here is n to represent the number of sides, and then a colon. And then inside of this, what we want to do is move our turtle some particular distance. So I'll say t dot forward, and for right now we'll say that we move 50 pixels. So we'll say 50 here. And now we need to figure out the angle that we need to move. So after we draw a line with our turtle for 50 pixels, then we have to move some particular angle. And let's go ahead and just calculate the angle that we should be moving based on the polygon. So I'm going to just have a variable here called angle, and then we'll assign to angle some particular value. And if we remember our formula, we can take 180 and multiply it by the number of sides that we have, so n minus 2, so n representing the number of sides. So take that quantity and then divide it by the number of sides. And that's pretty much it. So this calculation here should be the only thing that we need to have for calculating the angle that we have to move. We may make some mistakes here, so we're just trying to work through this. If we make a mistake, I think that's actually a good thing. We can see, logically or syntactically what the problem is and move on from there. And sometimes I try to make mistakes intentionally just so we can learn from those mistakes. What we're going to do is imagine either turning left or turning right by some particular angle. So I'll say we'll do a turn left, and we'll turn left by that particular angle that we calculated. So again, this thing here is just making use of that formula that we looked at before in terms of calculating an individual angle within a regular polygon based off the number of sides in. So we have that. So I'm going to move down and draw our polygon. So I'm going to just call the draw our polygon function, our procedure that we just wrote, and pass in the value of 4. So you can imagine that that's going to draw a square. So let's go ahead and save this. I'm going to apply a name to it this time. So I'm going to go ahead and save this and specify a particular name. I'm going to say that this is our turtle polygon, and I'll replace that. And now we'll run it. So you see that as our procedure is written, it does in fact draw a square. Now let's test out this procedure and see if it's able to draw some other polygon, because we said that this is supposed to be able to draw any type of regular polygon that we desire. So as long as it has 3 or more sides, we should be able to render it. So let me close this out and change this. Let's just try out a triangle and see how that works. So we'll save this again and run it. And yeah, we didn't quite get a triangle. We did get something with 3 sides, but the thing that we got is not in fact a triangle. It almost looks like the start of a hexagon instead of a triangle. So we need to go back and look at our draw polygon, because the problem no doubt is within our draw polygon procedure here. We're in fact doing something 3 times because we ended up executing this T forward 3 times. So that's not the problem. It looks like we have an issue here in terms of the angle that we're using. Maybe the angle's fine to some degree, but not exactly right. So if we look here in our turtle graphics here window, we see that we went straight, and then we turned whatever we have, whatever we computed this angle to be. So in the case of a regular triangle, or equilateral triangle in this particular case is what we would formally call it, we should be turning 60 degrees. And we are in fact turning 60 degrees, but we really should be turning the supplement of 60 degrees. So we'd really need to be turning 120 degrees as opposed to just 60 degrees. So what we need to do, if you can see that, is this here, we're turning 60 degrees to the left and then drawing this angle and then turning another 60 degrees from here and drawing that angle. We actually need to be turning the supplement to actually create the proper interior angle for our triangle. So the way that we will do that is here where we have t dot turn left, in order to figure out the supplement angle, we would just take 180 and subtract off the angle that we calculated. So let's save that and run this again and see what happens. So yeah, that time we drew a triangle. Let's see if we can try something else. Let's try going to a pentagon, see what happens. So we'll run this again. If you don't save it, it will save before you run it. So we ended up with a pentagon, and you can imagine trying out other things as well. And if we wanted to, we could be a little bit more generic here, where we have this draw pentagon, and we could nest this draw pentagon procedure call inside of a for loop. So we could say something like for I in range, and then maybe specify, I don't know, let's specify a range this way. We can actually specify a starting value and an ending value. So we could say something like 3, 11. Now it turns out that the 3 what we use, so we draw a triangle, that would be a 3-sided polygon, but it actually goes up to but not inclusive of the second value, this ending value here. So it use the value of 10 but not the value of 11. So it's up to but not inclusive of this value whenever we specify a range in this case. So typically we've just been specifying a single parameter, but you are able to specify 2 parameters where you provide a starting value and an ending value, and it goes up to but not inclusive of the ending value. So we'll do a colon, and then we'll come down to the second line and tab that over. And let me return this a couple of times, press enter a couple of times so we get a little bit more space. And we'll save that and check this out. Oops, looks like I have a problem there. I forgot to change what? Well, I did do something from 3 to 10. So I did 3, 4, 5, 6, 7, 8, 9, and 10. The problem is I was drawing a pentagon each time because I didn't change this value of 5 to I. So let me close that. So that's a mistake on my part. I got talking about too much here. So let me change that to I and save this, and let's run it again. All right, so we got a triangle, a square, a pentagon, a hexagon, a heptagon, octagon, nonagon, and a decagon, I think, is the names that we have for those particular polygons. Hopefully I got those right. So that's pretty much it for this particular video, and I think in the next video we'll look at doing some decision structures. So for right now we've been introduced to doing a sequence of instructions, also being able to do repetition, but we haven't looked at how to make some sort of decision. So if this is true, let's do this. Otherwise, maybe we'll do something else or nothing at all. So that's it for this video.